Hello, boys and girls and Cougar parents. Today we are going to take a look at literal equations and how to solve them. The interesting thing about literal equations, for the most part, you're really not focusing on finding a numeric value as your answer to the unknown variable, as much as what you're trying to do is you're trying to solve the variable in terms of the other variables that are in your equation or in your formula. Let's take a look at a few sample problems together. Well, boys and girls, let's take a look at numbers 1 and 2 from our homework tonight. We are solving literal equations, and we look at the first one. We have P is equal to IRT. Okay, and we want to solve for T. Now, right away, you might be saying, how can I solve for T when I don't have any numbers? I don't know what P is, I don't know what I is, and I don't know what R is. Okay, and by the way, this is principal is equal to the initial amount times rate times time. Okay, this is a economics formula that we use. But the goal for solving an equation, whether we have numbers or not, is to isolate or solve a specific variable. And the variable that we want to isolate is t. And how do you isolate the variable? You isolate the variable by performing inverse operations. So I take a look at t and I ask myself, what is happening to t mathematically? Well, it's being multiplied by the I and the R. Well, the inverse of that is to divide by I and R, and that's exactly what I'm going to do. Divide this by IR to remove it. And what I do to one side of the equation, I must do to the other. So I also have to divide P by I and R. And again, I'm using this fraction bar as my division bar. And the I and the R will cancel out, and I'm left with T over here is equal to P divided by IR. And I can flip it around. I know some mathematicians are real sticklers about this. I want to solve in terms of T, so I'd say T, therefore, is equal to P divided by I and R. Number 2, we can do in similar fashion. This time we want to solve for W. Now, W it says area is equal to 2 times the sum of the length and the width put together. Well, first thing I want to do is I want to get rid of this 2 here, because I can't really work inside the parentheses until I get rid of what's on the outside first. And the goal again is to isolate W, to get it all by itself. So the first thing I'm going to chip away is this 2. And this 2 is multiplying itself by the sum of this parentheses here. So I'm going to divide this whole thing by 2. And what I do to one side of the equation, I must do to the other. So that gets rid of the 2, and I'm left with length plus width over here is equal to area divided by 2. W is almost by itself, but it's being added on by L, so I'm adding L to it. So what's the opposite of adding L to W? Subtracting L. So I'm going to subtract L from this side, and what I do to one side, I need to do the other. So I subtract L from both sides. The L's cancel each other out, and I'm left with W over here, and over here I have area divided by 2 minus L. And I can flip this around and solve it for in terms of W. W, therefore, is equal to area divided by 2 minus my length. Our next 2 examples are going to be problems 5 and 6. In 5 here we have the sum of x and y divided by 3 is equal to 5, and I want to solve for x. Okay, the first thing I want to do is get rid of this funky fraction. If I want to isolate x and get it all by itself, I want to get it out of this fraction mode here, so I have to multiply. Whoops, I need to get my pen working. I'd have to undo this divided by 3. I'd have to multiply by 3. And what I do to one side, I have to do to the other. So there, that would cancel out. And then I'm left with x plus y is equal to, well, 5 times 3 is 15. Okay, and I almost have x all by itself. I just have to get rid of this y. And since the y is being added to x, the inverse or opposite of that is subtracting by x. And what I do to one side, I need to do to the other. Okay, the y's cancel out here, and I'm left with x is equal to, whoa, hold on. Okay, I meant to put a y there. Okay, I have to subtract y from both sides. What I have is x is equal to 15 minus y. And there I solved in terms of x. Number 6, okay, I've got the slope-intercept form over here. Y is equal to mx plus b. You guys should be pros at that. We want to solve in terms of b. And this is pretty simple. What's happening to the variable b, which I want to isolate? It's having m and x added to it. So what's the inverse of having m and x added to it? Subtracting m and x. And what I do to one side, I need to do to the other. Sorry about that, mx. And sometimes this is nice to just draw a line straight down. And what I can say is the mx's cancel each other out. Okay, and then b is equal to y, bring down y, minus the mx. And I can flip this around and solve it in terms of b. b is equal to y minus m times x. And there's my answer. Finally, let's do two more problems, and I think the rest you should be able to handle on your own. Number 11, we have volume is equal to pi r squared times the height. Okay, well, we want to solve in terms of h, and this looks kind of scary at first, but once again, ask yourself, what's happening to h mathematically? Well, it's being multiplied by pi r squared. And what's the inverse of that? Divide by pi r squared. And what I do to one side, I need to do to the other. So I have to divide this side by pi r squared. The pi r squared is a factor of both the numerator and the denominator here. So they factor each other out, and I'm left with h is equal to this side of the equation, which is v divided by pi r squared. And I can flip this around and say h is equal to volume divided by pi r squared. And I'm done. What looked kind of scary and intimidating was actually one of the easiest ones. Number 2, okay, there might be I think one more step involved here. I want to solve in terms of x, and I have 7x minus y is equal to 14. Okay, well, what's happening? Is there anything being added or subtracted to our variable that we want to isolate? And yeah, we're subtracting y from it. We're going to take care of that first. And what's the inverse of subtracting y? Well, that would be adding y. And what I do to one side of the equation, I need to do to the other. So a negative y and a positive y cancel each other out. I bring down my 7x is equal to 14 plus y. And then I ask myself again, okay, x is almost isolated, but it's being multiplied by 7. What's the inverse of multiplying by 7? Divide by 7. And what I do to one side, I need to do to the other. The 7's cancel each other out because 7 is a factor of both the numerator and denominator. So x is equal to 14 plus y divided by 7. Now we could take this one step further. Okay, I could factor a 7 out of the 14, and you could also write it like this. So 14 divided by 7 is 2. I just have to distribute, plus y divided by 7. See, what I did was I need to divide both of these terms by 7. It's kind of like it's doing the distributive property, but instead of multiplying, I'm dividing both terms by 7. And here's my final answer in simplest form. I will see you tomorrow. Bye-bye. As always, I hope that was helpful, and if you had any problems that were not covered in this video that caused you difficulty, please bring those problems to my attention tomorrow and we'll hammer them out. Have a good night, and I'll see you tomorrow. Bye-bye.